Hello guys, so today we will create a dataset for fine-tuning stable diffusion. So in this dataset we will have images and their respective captions. So let's get started. So first of all, we will need images for this process. So in your case you will have your own images on which you want to train or fine-tune uh, stable diffusion. So we have to create a dataset from that images. In my case, I will scrape images from my own account. So I created a script and this file. So I will run it to scrape my own images. So this after running it, I will go to my account. This is my Instagram account. So I need my this username. So I'll come here and then paste it here. So it will start scraping my account. So it will take a while. So it is completed. You can see all the images are scraped. So let's go to the this folder. Here we have this images folder. Inside it, my all images are scraped here. You can see. So now the next step is, so in the next step, as I told you, we have to create a folder here with name images, and then inside it we have to upload all these images. So you can see all the images are in uh, this folder here. Okay. So now our next step is, I will recommend to create a virtual environment for this. After getting a virtual environment, you have to install Jupyter. I'm using Jupyter. It's upon you. You have to install Jupyter. Okay. After installing Jupyter, uh, you have to install some dependencies like these, pillow transformer, and I'm also using this TQDM. And then you have to install some other dependencies like uh, transformers and datasets and pandas, uh, torch. So I also have a GPU in my machine. So if you have a GPU, so you have to install a particular variant for you. Okay. So is like for example is Pinto, and you have a CUDA version of 12.1. So this command for me, if you have just CPU, then you have to install this command. Okay. If you are using pip, so this one is for you. Okay. After that, after installing all the dependencies, we have to run this. So for that, just refresh it, and then there are two methods. So first of all, we will see the first method, and then we will see the second one. Okay. So in this for this in this tutorial, I'm using the uh, this model. I will show you. It is from SalesForce. So here, so this is a SalesForce model. I will show you. This is here. I'm using this model for captioning. Okay. So now in our scenario, we have these all images. Okay. So now we have all these images. So we have to caption all these images. So we for that we will be using this model. So I also have CUDA. If you don't have CUDA, you just write CPU here, like CPU. Okay. So I have CUDA, so I'm using this command. Okay, so it will install the this model. Okay, from Hugging Face. So it will take a little while. So the model is loaded successfully. After that, this function is for to generate the captions. We will see it in a little while, and see these are maximum tokens. So I pass 75. You can pass 100, 200. It's upon you, but Stable Diffusion accept 75 to 77 token caption. So that's why I'm using 75, and then it will return the result. It will be generated text. It will be a caption. Okay, and this function. Okay, run this function, and this function you can see it's saved to CSV. So our end uh, end result will be saved in the captions.csv file. It will contain the image path and also the captions for every image. So run this, and here it's a process. Okay, so a process image function. Here you can see it will take images from a directory. This is a directory, images directory. It will this function will load the images, and then it have to process the images also after that. Okay, run this, and then this is a main function, so it will call the process images, and then it will inside the process images it will also call the generate caption function, and inside generate caption function uh, there will be save to CSV. Okay, so here is also a save to CSV function also called inside process images. So now just run this one. So all the images are loaded and processed successfully. So if we refresh it, so here we can see a captions.csv file is ready. Inside this we have image the path to the image and also the caption for every image. So here is this image. So we'll just open it. So here you can see uh, what is the caption. There is a man standing in front of a building with a smile on his face. So here is a building, and then okay, and there are all other images with their respective captions. Okay, after that this is method number one. Okay, so in this method it takes a little long. uh, we can make it a little bit faster with datasets library. Okay, for that you can see we have a CUDA uh, available. So after that this is method 2. In this method we are using dataset libraries, so it's an optimized way to caption all the images. You will see in a while. So in this example we are also using the same captioning model. This generate caption is this function is the same as above. Also the process one is the same. It's just here it's a difference because we import datasets, and then here you can see from a dataset. Here's a dataset. From dataset we are mapping the gen this function. So this function take the path to the image and then generate a captions. So it also called the generate a caption function, and after that it will give us a processed dataset. So it will also print one sample for us, and then it will return the data process dataset. So it will be saved in a metadata.csv, and it will contain it will contain columns like file name and text. Text will be the caption. Okay, that's all. So you have to just run it. So here you can see it is running. It's take a little while. Okay, it start. Here you can see 3 to 3.5 examples per second. If you have a huge data set, so this second method is uh, more efficient for you. It will save your time. So here you can see, just go here and then refresh it. Just open it. Okay, so here you can see we have a metadata file inside here. I'll have these are the path to the image, and there, this is the caption. So here you can see similar captions or somehow. So this is the data set. It is ready to for fine tuning. So thank you so much. See you in next video.